All righty. It's a very full room. Before I get started, help me understand who I'm talking to here. How many of you use Kubernetes right now in your day job? Wow. How many of you have been using Kubernetes for more than a year? 2 years? Okay, great. How many of you are using a service mesh in production? Yeah, that's what I thought. How many of you have tried a service mesh? How many of you want to explain to me what a service mesh is? How many of you have tried Linkerd? How many of you have tried Linkerd this week for a hat? Okay. My name's Oliver. I'm the CTO of a company called Buoyant and the creator and lead engineer on Linkerd, which I hope you've all heard of before, I think. Stragglers, I got some room for you right in front. Come on up. Come on. That's my dog, Presume. And I chose this handle in my 20s, and I'm stuck with it for the rest of my life. So you can find me at Alex or basically anywhere. So a brief history of Linkerd. Oh, before I get too much into this, it's going to be a pretty loose talk. I'm here to be able to answer questions for you mostly, but I have some things I want to get through. If something really catches your interest as we're going through it, stick your hand up, and we'll try to deal with it while we're going there. We don't have too much time, but I want to keep it flexible for you. Anyway, going back a couple years now, we started working on Linkerd in 2015, released it in 2016, very early. We spent about a year working with a bunch of you, some of you are probably in the room, to get it into prod in some places. This was a big JVM-based Linkerd made for Mesos, Kubernetes, any orchestrator you wanted, even none, just very flexible piece of tool. About a year later, we donated that to the CNCF, which is a great decision in my opinion. Introduced me to all of you, for instance. And fast forward a couple years, Kubernetes took adoption, and that really pushed us into a sidecar model that we didn't anticipate starting on. With Linkerd 1, we had kind of assumed, well, you just run one of these per host. Before that, I had been working at Twitter, where we ran Aurora and Mesos in production, and a host-based daemon was fine. But going forward into Kubernetes, we look at the new pod model, and beautiful pod model, sidecars I can put on things. Putting a JVM sidecar on every 10 meg Go process is not something most of you want to do, I assume, or at least that's the feedback we got. And so we spent a lot of time retooling, and we launched something at KubeCon in 2017 called Conduit. Did anyone try Conduit? Cool, your early adopters out there. And that was our kind of approach to do it all over again. If we were going to start over with all the lessons we did with Linkerd 1, what would we do again? And it's focused on kind of being lightweight, simple, and focused on the essentials and not all of the configuration that Linkerd 1 had. Very minimal, basically no configuration. Similarly, we spent 9 months or so, no, more than that. We spent a year and a half or so. No, we spent about a year. Can't do math in my head. We spent about a year getting users of Conduit, getting feedback, figuring out if it was a total waste of time, we had to really invent a whole new tech stack to get there, or if maybe it was a good thing. And we got a bunch of feedback about Conduit. It's very early, not really used widely at all. But we felt confident enough to kind of bring it into the Linkerd project and promote it as Linkerd 2 because we think it provides the same value proposition, but much better and very coupled to Kubernetes. We really don't support non-Kubernetes environments in Linkerd 2, and I love that decision. It really lets us simplify. I'm required to show you this by my team. Linkerd is used all sorts of places. I've been in prod for a long time. We've got a lot of, 10,000 GitHub stars if you add them all up. I don't know what that means. We've got a lot of interest, and these are just the kind of the big names that you've probably heard of. But more importantly, it's running in lots of small shops, helping people solve kind of the getting started problems. Like going into Kubernetes is a daunting experience, and adding some other layer of complexity on top of that, like another set of API platforms and a big complicated service mesh is not what we want to do. We want to add debuggability, operability, visibility easily. And so it's way more used outside of these large organizations than in them. But it's used in both. Ground rules for this talk. I'm sorry, there have been many Linkerd talks this week, but I'm going to set some ground rules. I'm happy to talk about what Linkerd does, why it does it, how it might do it in the future, how you should do something with it. I'm not here to talk about how Linkerd compares to X, and I imagine you can all guess what X is. But anyway, there's a booth in the vendor hall. You're welcome to go ask them. They love talking about that. But I want to use my time for something else. OK, I'm going to go through just a kind of quick overview of how Linkerd works. We can jump into some code if it's going to be helpful. Before I go there, how many of you have written Go? OK, how many of you have written Rust? Good. In a year, it's going to be a lot more. Maybe 2, but it's on the way. So Linkerd 2, it's this GitHub repo. This is the Go repo. This is where we have all our issues. This is a good place to get started and get in touch with us or start browsing around. And when you install Linkerd, you kind of get this hand-drawn deployment. Here we have a Linkerd namespace. It has a bunch of very tiny Go processes that are responsible, basically Kubernetes controllers. They talk to the Kubernetes API. They expose gRPC interfaces to the proxy or to the tooling, the CLI, et cetera. We use the API server for authentication and all the stuff that you're supposed to use the API server for. And then we have these proxies, and they have IP tables at the start of the process, either via CNI or in a init container that forces all of the TCP traffic, asterisk, through the proxy. So all the inbound traffic goes through one port, one route. All the outbound traffic goes through another. And that's the basis for what we're going to talk about the rest of this. So if this is confusing, stop me now. OK. But it's actually a little better than this. We don't have to use hand-drawn tools. Linkerd itself can tell you how it's deployed. This is the whole point of using something like Linkerd. So the Linkerd control plane itself has the sidecar, the Linkerd proxy, injected into all the controller pieces. This means we get visibility on the control plane by default. It's the snake that eats its tail. It's basically like that. And so here we see that we have several containers. They're all doing a little traffic. Most of them are just doing health checks at this point. But because we're loading the dashboard, we see we're querying Prometheus. It's quite clear just here. But I can get a little better than this. If I click on that controller thing, ooh, did I? Well, OK, lost the slide. Maybe it'll come back later. I don't know. And so what I want to talk about then is the data plane. And this is where I spend most of my time. I do work on both sides of the equation. If you looked at those GitHub stats before, the proxy is like, or the Linkerd 2 repo is about 80% Go, or 70% Go, 20% JavaScript, and the rest of it's shell scripts and YAML. Probably more YAML in there than that's accounted for. Linkerd 2's proxy is in a separate repo, and you see that's basically entirely Rust there. And over the past year, certainly since we last spoke, we've really been in the process of factoring pieces out of the proxy into a common set of libraries called Tower. And this is a part of the Rust ecosystem that anyone who's used to Linkerd 1's initial stack, finagle, this is going to look very similar. The goal here is that we have a bunch of reusable components that we can use to build things like proxies or web apps. We have gRPC implementation in here. We have a whole bunch. Retries, timeouts, load balancers, routers, you name it. And that's good because we're making the proxy's code base much smaller. Those Tower libraries are being used to drive a whole bunch of production applications in companies you've heard of that I'm not allowed to talk about, I think. And yeah, we're getting benefits by putting the reusable pieces of Linkerd into the community, having other people work there and contribute back. That's been working really well. So if Rust is interesting to you, Tower is a great place to get started. It's still pretty new, but that means there's a lot of opportunity. Oh, and here we go, my old slide. Sorry about that. What we also get here is if we clicked on the controller, we can actually get topology information. This is actually maybe cooler than it seems. So we're looking at deploy stats here. And the way we're doing this, we have traffic stats, right? We say this controller calls Prometheus, and it calls the tap service, and it's called by the web service. That's done without any instrumentation of the application. And it's done only via Prometheus stats. And the way we do that is we have a whole bunch of Kubernetes-specific metadata in the stats that the proxy emits. So we can actually say, what's the success rate to this deployment? What are the deployments you talk to? This all comes from Prometheus. meaning we don't need tracing. And this is something I really want to be heavy-handed about. I've been asked many times this week, why doesn't Linkerd support tracing? And the reason is because tracing requires that you change your application. If your application doesn't participate in tracing, at least forwarding headers, tracing is useless. And so we don't want to require you to change your application. However, if you do use tracing in your application, Linkerd won't break it. It'll work just the same. So no harm done. But without tracing, we can give you topology information. We can give you call graphs, all based on the metrics. OK, so once you've installed the control plane, and it's all running fine, now you need to go start adding the proxy to your applications. Excuse me. In order to do that, we initially started with the CLI tool, the Linkerd command. You can run Linkerd inject, you give it your YAML file, it would read all the YAML, add a bunch of proxy YAML to it, spit the YAML back out, and then you kubectl apply it. Recently, we've changed that, and in 2.4, this is going to be a lot better. And so now we have a mutating webhook controller that's required, and that does all of the proxy injection. And so now when we do an inject, we add a single annotation onto your pods. As those pods get created, they get called through the webhook. We add the proxy, and they get written back. It means to upgrade the Linkerd proxies, if you do a control plane upgrade, you just need to delete pods. As they get recreated, they'll get the new proxy versions of the new configuration. It's a much simpler model, a lot less manual. However, you can also do Linkerd inject -- manual and get the old behavior. We're not breaking anything there. Point is, once you do it, you'll get a proxy init container, which does the IP table setup, and a proxy container, which is going to receive all the inbound and outbound traffic. If you're sensitive to using netadmin in your pods, we have a CNI as well, so this can all happen before the proxy gets scheduled. OK, now my favorite part. Let's talk about the proxy a bit. So in 2.3, which was released about a month and a half ago or so, we introduced automatic mutual TLS without configuration. I see you squinting. I'm sorry for my handwriting. If you can't guess, I was doing this earlier today. I'm a content person, not a pictures person. But the way this works is when the proxy starts up, it generates a key, a private key. And it also generates a CSR because it knows its identity, because as the control plane injected it, it said, proxy, here's your identity, and here's your trust root, so that we know how to trust other connections. We then generate our private key. We generate a CSR with the identity we created. We send it off to the control plane and say, oh, we also read a service account token from the pod. And this is an important detail. So we tie identity to the service accounts in the pods so that we have a way to prove identity to the Kubernetes API. And so as we read the service account token and the CSR, we send that off to the control plane. It then sends the service account token to the Kubernetes API via the token review API and says, is this person, or is this pod, this identity it claims to be? If the token validates, it comes back and says, yes, it's the default service account in the foo namespace. And then the control plane can sign the CSR, we get a certificate back, it comes back to the proxy for about a day. And so we rotate it about every 20 hours or so. That's a configurable timeout. And so these pods, the keys never leave the pod, they're stored in memory. We dynamically refetch them, and we're not using shared secrets. And this is very different from the initial TLS model we started with in experimental months and months ago. We've redone this in 2.3, and it's much better. And so this can just refresh, and it works pretty well. Also, the identity service can be replicated, and currently it bundles its own CA, just so you don't have to go provision a CA in some way to get started. But we're looking going forward and integrating with cloud providers as backends here. So if you're in AWS and you want to use their CA, you can use that. Or if you're in Azure and you want to use KeyStore, you can use that. Or if you want to use a HashiCorp Vault off a cluster, we don't want to own the key management part of this. We want to integrate with other things there. Any questions on this before I plow forward? We'll try to have some time at the end too. OK. OK, so once we've done that, and the proxy basically will start waiting for this validation. And once it gets a cert back, it actually hits readiness. And so it will not advertise readiness until it gets the certificate, so it won't join services, for instance, until it gets the certificate. So as soon as it gets the certificate, we're good to go. Then we can start serving traffic. And as we get a request, or a connection into the proxy on the inbound router from another pod, we do a few things. And part of Linkerd being a no configuration system means we have to support arbitrary protocols in the proxy transparently, which is a little bit of a challenge. And so we do this in a few ways. One, as soon as we get the accept the socket, we look at the SO original dest. Anyone familiar with this? The way IP tables rewrites work is when IP table says, instead of going to this thing, you go over there, you can actually ask the kernel and say, where was it originally going? And so when we get an exception that was a connection that was sent to us, we can ask the kernel, which port was this originally headed to in the pod, or which remote IP and port was this heading to out of the pod? After that, we try to do a TLS decode. And that little skull is because I drew this 6 months ago, and we've replaced the iNotify piece of this. And so we already have the certificate, we know our identity, and we say, okay, let me try to read a TLS client hello message. If I can read a TLS client hello message, I'm going to check its SNI, server name identifier. Based on the SNI, we say, is this TLS connection coming to me, an identity in the mesh identity, or is this foo.example.com? For instance, if this is an ingress, we don't want to terminate TLS here. We want to let the ingress terminate TLS. And so if it's not to us, we just forward it along like it's pure TCP and we can't see it. If it is SNI to us, we decrypt it, and now it's clear text, and we can start doing more. Then we do some TLS or some TCP metrics. We get the number of connections, the bytes sent, all of that stuff. And then we do protocol detection. So this is pretty simple. It's just like the file command on your Unix laptop. It looks at the first few bytes of the client message and says, well, does it start with HTTP space? If so, it's an HTTP1 message. Or maybe it's get space. So just start with a verb. Does anyone know the magic for HTTP2? It's pretty cool. It starts with something called, I think, SM star. SM is special magic. Very, very clever. And then we can start to do other protocol detection there as we add more codecs into the system. However, there's a bit of a gotcha here. Not all protocols are client speaks first protocols. The two best examples I know of are MySQL and SMTP. And so if you have a system that uses those protocols, what we require that you do is set a skip ports flag. And what that does is when you set that on your pod annotation as a, for this pod, skip the ports 3306 and 25. We skip those by default, by the way. And that means that none of those connections will go through the proxy at all. They'll just go plain through without the proxy. And that way we don't break MySQL. I think eventually we'll want to have some way to have the proxy support those things, but our mission is to make things work without configuration, not to satisfy every corner case that you might have. Oh, that's a very polished slide I have there. And then the other part of this is when we're going to send a request outward. And so I'm a client of another service. What we do here is that we actually take HTTP1 requests and HTTP2 requests, and we all treat them like the same thing in the proxy. It's just HTTP. And so that means all of our middlewares are generic over those details. And we only really deal with it on the service on the client side. But the main routing logic is host header or authority header based. And so we don't want to require a lot of configuration for this. If you've already set up Kubernetes services, we can just work in that world. Or if you're talking to Twitter.com, that'll just work. And the idea here is that your application has already resolved the host name, so we know it's a real host name. We get or we hope. If not, it's not going to totally break, but it might be confusing. So first we look at the authority or the host header, or we may actually look at the L5p dest override header if you set that via ingress, so we can use that instead of the authority. And if we actually don't have any information to route on, we'll fall back to the original dest address that you were using, so we can just forward it without any special magic. Then we have a little bit of a challenge. So in the Kubernetes world, you can put crazy DNS policies in your pods. You can have all sorts of awful logic in there that I don't want to know about. I definitely don't want Lincolni to know about. And so what we do is we just re-resolve the name that you put in the host header. So if you send a request to foo, and it happens to resolve to foo.default.service.cluster.local, or maybe resolve to something else, but we do a reverse DNS lookup until we find the fully qualified domain name, and that's actually what we're going to route on. And for now, we only will do discovery, load balancing, and identity for configured suffix, which is, at the moment, service.cluster.local, but that's obviously going to have to change to support named clusters, which are a really annoying thing. If anyone has ideas about cluster name discovery or any of that stuff, find me after. The point here is we have to get a canonical name because all the policy will hang off the canonical name, and we don't want to be up to interpretation. And then we do something called service profiles. And this basically routes or HTTP routes, so matching requests by verb and path regex or something like that. And so we can get per path stats, or per gRPC endpoint stats in this way. And so you can take a gRPC protobuf spec or an OpenAPI Swagger spec, basically just give them the Linkerd. We'll read them, turn them into a service profile so that we can configure Linkerd based on those. You can also set retries and timeouts based on that, and we'll be adding some other configuration onto that soon as well. And if you'd like to see anything else that you can hang off of a route, PR is happily accepted with some review. The point is we get metrics, we know whether it's a success, we can have per endpoint success or failure characteristics, or retriability, and that's all gone there. And then, once we've done all that, we go to the service discovery and load balancer. So we take that canonicalized name that we resolved before, and we say, do I know the suffix? If it's service.cluster.local, I know I can look it up in the control plane. So I try to go do that. When I look it up in the control plane, I say, well, okay, foo.default.service.cluster.local. This is the foo service in the default namespace. I'll go resolve that via the Kubernetes API, get all the endpoints, get all the pods. It's a really overly complicated process, but we've got that down by now. And with that, we can actually read all the pod metadata as we do that. And we actually can take labels off the pods and put them on the response that we give to the proxies. And that's how we hydrate the metrics that we were looking at before to have topologies. This all comes because we can read this from the discovery system. Also, this is where the identity kind of kicks in. So when you inject a proxy, or when the proxy injector is adding the proxy to a pod, it knows whether identity is enabled on that pod. By default, we enable it. You can forcefully disable it. If identity is supported in that pod for mesh communication, we know we can select on those by label, and we know we can look at those and send them TLS requests. If they're not injected with that configuration, we don't try to do TLS to them, and we just treat it as plain text. This all comes back from the discovery system. The important detail here is that you don't have to install Linkerd on everything. You could install it on one service that talks to other services, or a subset of services. We'll do meshed stats, telemetry, identity, all that stuff within the mesh services, and all the other ones will continue to work happily. You'll just be a little blind and clear text. We used to, actually in 2.3, we still do this. Tomorrow we're going to merge a branch that removes DNS fallback. We used to go do another DNS lookup if we couldn't resolve the name through service discovery for some reason. The idea there is that we want to do load balancing potentially on other names that we don't know about. But that actually makes ingress much, much harder. So we're just going to tear that feature out and drop it on the floor. It's great. I love deleting code. It's like the best thing in my job. The load balancer itself is a P2C peak UMA load balancer, which is the same thing we use by default, I think, in Linkerd 1. Alex, am I right on that? Yes, I am. So what that P2C peak UMA load balancer means is that we're watching latency to each endpoint that we're talking about and keeping a weighted moving average of each. And so P2C means we pick two at random. There's this great paper that's basically you can maintain a heap. It's really costly to maintain a large heap of 1,000 nodes. It's statistically equivalent to pick two at random, compare their weights, and use the cheaper one. And so that's what we do, and it works great. It's a constant time load balancing algorithm, and it's latency aware, and that's awesome. We really recommend using this. And a lot of people just deploy Linkerd just to get gRPC load balancing that's latency aware. Any questions on that before I tap dance on? Yeah, right up front.
Does it take time to query the control plane?
Yep. So does it take time to query the control plane? Because this is in the request path, right? We have all these lookups going on in the request path. That's a really good question. It does the first time. And so the first time we're going to go process a request to a new endpoint, we start a gRPC streaming response from the server. And so then we're constantly getting updates from the destination service about as pods change, et cetera. And so we only pay that latency cost in the first request. Once it's cached, we have our load balancer set and we're ready to roll. As further updates come in, that doesn't affect the request latency. Good question. Yeah, and so as we get those updated pods, so the question is, can we get updated information? As we get updated pods, all the new metadata comes back. We have per pod identity, the metrics, it's all dynamic and lazy. Yeah. I see. So if you remove Linkerd from another pod, does Linkerd maintain its identity configuration? No. No, it all gets pushed back down to all the proxies. So when you change any pod config, it's going to go push updates to all the proxies that are watching that pod's state, or the service that includes those pods, rather. Good questions. There was another one. Okay. All right. Yeah, we'll try to make some time for the end. The endpoint stack. Again, I had to paper over some old TLS stuff that was there. And the endpoint stack is then for each endpoint in the load balancer, we have this stack of layers and services, basically a service hierarchy, much like Finagle. In that, first of all, we're like, do I do TLS on this, yes or no? We use that TLS configuration to inform the stats, et cetera. And we want to know the identity very well then. Again, we record lots of per endpoint metrics here. And so higher in the stack, we've set lots of context and information on the requests. So we can read it in the per endpoint stack and show you the latency distribution for each pod. We have very high granularity data in the proxy. It's again scraped by Prometheus every 10 seconds. We ship Linkerd with its own Prometheus that's tuned to be very small. It only has 6 hours retention. The point is there, we want this to be a cheap thing that's a escape hatch that you can use. This is not supposed to be your production Prometheus instance. What folks tend to do is they configure their production Prometheus instance to scrape from our Prometheus and just federate that so they can have longer term storage and drop any dimensions they don't care about, et cetera. Then we have this cool feature called tap. Tap's unique to Linkerd, as far as I know. And it basically allows you to push requests at runtime into the proxy. So instead of us logging every request and all the payloads and all the headers that go through the system, what we want to allow you to do is say, basically on-demand tracing. Go in this namespace, show me the requests that are gets to this service. And then you get a sampling from all the pods in that namespace of the requests to that service. Right now, this is really only request and response metadata, so was it successful, what path was it, et cetera. We're in the process of adding full headers to that and ultimately full payloads to that, which will be awesome in my opinion. The work that's kind of blocking that is we are in the process of RBACifying all of this. The idea that we're going to ship all your payloads to anyone who connects to a proxy in this port, no. So we're in the process of making sure that the tap server itself has RBACable permissions, and you can, if you have access to read those pods, you'll be able to tap them, and if not, you won't. And after that, we'll start shipping you full payloads and headers and all that good stuff. And that's in flight now, and definitely an area where folks could contribute if you care to. Another thing that we do in Linkerd 2 is, because we have a proxy on both sides, we can make collusion decisions. We do this for identity. We can also do this for protocols. And so if you're using HTTP 1 or 1.0 or some terrible thing in your application, we will do HTTP 2 between the proxies. So that means every proxy will have at most one connection with every other proxy. The advantage of doing that, especially with TLS identity, is that we only have one TLS handshake per proxy pair. So we do multiplex communication of all of your traffic, all of your HTTP traffic through these H2 tunnels, which is really nice. And if you're using H2 in your app, it just layers flawlessly, and it's great. And so on the way out, we say, does this other endpoint, is it a Linkerd 2 proxy? If so, we can upgrade it to H2. You can also disable this if you think it's sketchy, but it tends to be pretty good. And then we dispatch it on either an H1 or H2 connection. If we can't upgrade it, we just do normal HTTP1 like we should. OK, and just a little bit of forward-looking stuff. I think I have about 5 minutes left or so, so wrap this up. You all hear about SMI? Anyone not hear about SMI? Come on. OK. Earlier this week, Microsoft and Console and us, HashiCorp and Buoyant all partnered to launch what we call the Service Mesh Interface. It's a mouthful. And we're really starting there with what we think are the kind of 3 core APIs that we expect people to integrate with. And the idea here is we want folks who are building tools on top of service meshes to have good standard interfaces for the kind of core functionality. That being ACLs. I don't like the word policy. Policy is a big thing. Let's call it ACLs. Metrics. We got great metrics in our Prometheus. If you're a Linkerd user, you can go to Prometheus and get all the data you want. But what we've done is we've made that kind of a generic metrics interface, much like the metrics API or custom metrics API. It's an API extension that reads from our Prometheus. So any tool can query this endpoint if you add it. And whether you're using Istio or Console Connect or Linkerd, you can basically get the same metrics, which will really empower lots of dashboards and things like Flagger, et cetera. And the other part of that kind of Flagger story, for instance, is something like traffic management or traffic split particularly. And that's where we're doing kind of weighted canaries between services or traffic shifting between services. So you have an Apex service and downstream services or leaf services, and you can weight your traffic between those services. That we have a branch for that's not quite ready for master, but once I catch up on sleep, we're going to come back at it and get that ready for 2.4, probably towards the end of June, because I need a lot of sleep. All right, and then the other thing that we're really kind of keen on right now, as we've talked to people starting to use Linkerd, we realized that Linkerd makes many other tools better, and when you're using, for instance, a tracing system and our telemetry, you can do some really powerful things. And so what we want to do is not pull all of that logic into the Linkerd project as kind of a core dependency, but create more of an add-on system. So if you want to use an open policy agent, well, yep, you can go add that into the Linkerd namespace with some configuration, and we'll start hooking into that. This is still a big open area for design, and if you have thoughts or desires or dreams, get in touch with us and tell us what we should do there. For instance, right now we bundle a Grafana dashboard, and it's a nice thing to have by default, but it's also kind of a big dependency for the quick getting started thing. So we'd like that to be an add-on, for instance, where we can just have that pop up in the dashboard if it's present and not be there if it's not. OK, finally reaching the end of this. I hope you've caught my message here that I hope some of you leave here wanting to get involved at least a little bit, maybe pick off some getting started issues. If you go to our GitHub, we have a bunch of help wanted and getting started issues. And it's really a growing and healthy community. So please do get involved. And you can always join our Slack. Again, lots of people asking questions, especially this week. Lots of people answering questions who don't even work on Linkerd, which is my favorite thing. And yeah, we're all on Twitter, et cetera. And with that, I'm going to open the floor to questions. So anybody got any? All right, so let's see how this works. I think we're good there.
Hi, I have 2 questions for you. First is Mutual TLS for ingress.
Yeah.
I think you don't support it currently. And if you have something like guideline, what we should do instead.
Yep.
And second one is something like service entry from Istio, that policy saying, OK, from these spots, I can call outside the cluster only to these, if you are supporting it.
OK, good questions. even though you asked me to compare, but yeah, that's fine. I know, I know. Yep, I'm kidding. Yep. So the first one was ingress mutual TLS, and maybe ingress in general is maybe a better thing to address there. There are many very good ingresses out there that are full-featured and have lots of features you already depend on, and I kind of believe they don't belong in Linkerd, or at least not yet. And we want to be really good at east-west traffic and not north-south. And so what people tend to do is they run any off-the-shelf ingress and inject it with Linkerd. And so that will handle the mutual TLS outside. You have to go talk to Ambassador or Nginx or any of those to figure that out. And then once it hits the mesh traffic, we'll take up the mutual TLS inside the cluster. The next question was kind of egress policies, right? That's a really good question. So one of the other topics that I didn't highlight there is we're starting to think through the multi-cluster story a little bit more seriously. This is obviously a big theme of this conference. And that's where we get into some more egress and ingress type things, even though I don't want to go deep down that rabbit hole. My answer for that would be, please open an issue. It's not something we spend a lot of time on because we haven't had many people asking for it. And the way Linkerd works is when our community is loud and vocal and clear, we listen. And when people murmur in the halls, we don't hear it and we don't work on it. So help us out. Okay, more questions. Got to be one or two. Can we pass this back to somebody with their hand raised? Or Kevin, you want to go run the microphone around? TL2? No?
Hi.
Sorry, go ahead.
The question is, do you have plans to support authentication or authorization in any form for the end users? So I mean like JWT tokens or OAuth or anything like that.
So do we plan to support user authentication, right? And so
yep.
We tend to see that as an ingress problem, right? That really users are not hitting things deep in the call stack generally. And so the people we've talked about this, we try to push them to make that an ingress problem, and then we have identity from there on. However, because once you're doing that validation, you're basically good if you trust that the mutual TLS is working everywhere else. However, we also have had folks ask for that feature. Again, it's not high on our priority list because it doesn't really fit the core use case we see. But we're open to it, so I think an issue would be a great place to start. If more than you just want it in here, then maybe we'll get some interest and maybe we'll even get some PRs on that.
Sure, thanks.
I'm going to hand that up to somebody. Yeah.
Thank you. I have a small question. Does Linkerd support port-to-port communication? Can I use it for headless services?
Can you use it for, one more time?
Port-to-port communication. For example, if I want to set up Elasticsearch, Cassandra, services which require port-to-port communication.
Yeah, so currently non-HTTP protocols, we just treat as plain TCP. We don't yet do mutual TLS on those, though we have some plans to do that. That's still kind of in that roadmap. So we don't add a lot there. It's, I think, a small add-on. However, it's possible and conceivable that someone could write a Cassandra codec, submit a PR for doing the protocol discovery, and then we're off the ground. So this is a thing where as we get the codecs in that tower library I was talking about, as we get features there, we will be able to pull them into the Linkerd repo as a more first-class citizen.
So there is no MTLS for such type of communication?
Not today.
Not today, okay.
But it's certainly on the plans for the next few months, yeah.
Okay, thank you.
And I should note, just in full disclosure, we don't yet TLS the, you can hand on the mic. We don't yet TLS the Prometheus scrapes yet either, though that's certainly on high on our to-do list. All right, are they give me the hook yet? We gotta go. One more? Any more? No more? All right, well, thank you very much. We have a booth in the vendor hall where there's plenty of people. We're all out of hats, I'm sorry. But other than that, I really appreciate you all staying to the end and hanging out with me in the talk. I hope some of you reach out to me on Slack and tell me that you were in the talk and give me feedback or bugs. I'm sure you'll all file bugs, but I like bugs, so file bugs and let's debug stuff together. Thank you very much.